Okay, I'm loud enough. I probably don't need this, but still, let's use it. I'll wake you guys up. Hopefully, you didn't have enough to eat. We're going to talk Passpoint. Passpoint is all about authentication. In Wi-Fi, since the beginning, we, of course, need to authenticate to a network to connect. And the first type is open authentication, which shouldn't be called open authentication because you're not authenticating anyway. You just go through a whole process of having, beacon, pro request, pro response, authentication. That's the open system authentication. Then you have an association request and response, and you're in. You get an IP address, and that's it. There is no place in a network for this. Well, actually, there is a place for this open authentication. When you're troubleshooting and somebody says, like, we have a problem with the Wi-Fi, it's not working, then scale all the way down to open authentication. No passwords, no nothing. And if you can go get an IP address, get online and back, then the Wi-Fi is good. Then start adding complexity to the network. Then we have PSK. We have a password that everybody has, that you can Google it. So, some organizations, I was at a school district, that if you wanted to know the password, Google it, and it will come up and tell you what the password was. So not safe, not secure, cracked, no place for it. But unfortunately, we still see it a lot. OWE, enhanced open, that brings another layer of encryption, and you can encrypt stuff without having a pre-shared key. It has its sets of advantages, disadvantages. You're still not doing any authentication. It's open. Then we have SAE, kind of like replacing PSK. This one, you have a pre-shared key or not, but then you'll have Diffie-Hellman exchanges. It makes everything more secure, but still, you're not keeping track of anybody because anybody can just log into a network. Anybody that meets those requirements. So if you have IPTLS, then now we have a more secure method. Radius is where we want to be. There's going to be exchanges in the air. There's going to be some exchanges between the authenticator and the authentication server. It makes it more secure. This has become like the most secure method for us to authenticate devices and verify credentials of a person in the network. So this is a more robust, more secure authentication framework. But not everybody has a radio server laying around, and who's going to maintain it? So yes, this is the preferred, but not the easiest. It's the more secure. So let's say if we have a university, and then let's call it the Red University. They have all the infrastructure, the radio server, and they have all the mechanisms to make everybody secure and authenticate. And now you have a username and a password, and you have a database, and you have a more robust, secure way to get people on the network. That's good. But then you have another university, the Blue University, and they also have their own really strong infrastructure. So what happens then when we have, let's say, a meeting, and then we have people from the Blue University coming over? How are we going to authenticate them in our network? Well, we could create a PSK network. Nah, not going to work. An open network. Nah, not going to work either. So they already have credentials in their home organization. How can we then link those together and establish a trust relationship? Then we'll use radius over TLS, and that will allow these organizations to kind of like exchange. And when somebody comes from the Blue University to the Red University, and they come to my network, I give them access, but I authenticate them against their home network. All the credentials will be verified over there. This is the basis of EduRoam. So it works great if you are an educational institution. So now they can go back and forth, and they can just authenticate against each other without having credentials locally or sending people to the front desk and get a password or have somebody invite you over to the network. That's way, way easy. This is not new. On the cellular side of things, the 3GPP, that's like the IEEE, but for cellular networks. So they have mobile network operators, And then they assign these numbers, the mobile network codes and mobile country codes, to these operators so they can identify them, and everybody's going to have their own. On the client side, each phone is going to have an identity. They're going to have a SIM card, a subscriber identity module, and then they're going to have, of course, a combination of if this phone belongs to this network in this country, they're going to have an IMSI, an International Mobile Subscriber identity. That's what an IMSI is. So that's what identifies the device. And then, of course, they had the same issues that we had in Wi-Fi, like how are we going to authenticate and validate credentials of these devices in the networks? Good thing we don't have to go through the whole process of searching for a network that we want to join, a tower, a cell tower that we want to join. So they do all of this automatically using IP methods, same as we do in Wi-Fi networks. It's just not called IP TLS or IP PEEP or IP LEAP or any of those IP methods we have. They have their own IP with SIM, and it's all about exchanging credentials. How are they going to verify identity of these devices? Then there is a newer one. It's called IP, aka the Authentication and Key Agreement. And then there is an even newer one, stronger encryption. The ciphers are stronger, are better. So this is like the latest and greatest that they have. Now, I know, it's exciting, huh? Not. Now, Passpoint comes into play. Now, Passpoint is not new. We talk about it and get all excited about Passpoint, like this is the latest and great. This is old. This is like from, I don't know, 2010 or 2012. And then they have their issues. How are they going to authenticate their device to the network? They figured that out. We figure out how to authenticate our devices in our network securely. And then what if we have people coming with their cell phones in our networks and they lose connectivity to their towers because, they are in the basement or they're inside the building. People start complaining the Wi-Fi is not working, but in reality is that their cell phone reception is not very good. So they say, how can we authenticate these people in our network? But we don't want to start creating accounts and passwords for everybody that comes in. So, hey, why don't we do what these other guys did and establish a trust relationship with their identity provider? They already have an account, they trust, and they have a SIM card that they can use. So why don't we become the access network provider, let them in our network, but kind of like what EduRoam does, we send them over to their network to be validated and make sure the credentials are good. So now, what organization is going to go out there, knock on doors, and establish trust relationships with all of these IDPs? Then it's really difficult to do, and not everybody is going to have the resources to go and authenticate everybody against everybody. So there are these brokers, these entities that exist to basically, you establish a relationship with this broker. They establish their relationship with all of the other IDPs in a way that when devices from different network operators come to your network, then you can just forward them for their IP exchange with their home network, and they validate them. Once they know they're good, then they're in. So this is the basics of Passpoint. In our case, the Passpoint we're using here, we're working with American Bandwidth. That's a company, a broker that has established relationships with T-Mobile and AT&T, the first responders in the US, and also you downloaded a certificate, and then that's how many of you got on that network without typing anything. It happens automatically. So how is that going to look in the network? If we have the SSID in our organization, these users connect automatically. That's like what we're here for. Okay, how do they connect without touching anything? You just walk in and you're connected. So in our network, it's going to look an anonymous username, and then notice the second part of that after the @ is going to be the domain where they belong, and they're going to have an MNC and an MCC, and they're part of the 3GPP network. So using DNS is going to send those requests to that server, that domain, and then it starts breaking it down and see who actually owns this guy, and then they send them over there for verification. Now, here's when open roaming comes into play. Open roaming is not a competitor to Passpoint. I get the question asked, like, so which one's better, open roaming or Passpoint? Like, that's not a comparison, because open roaming uses Passpoint, those same basic principles that we have talked about, because they say, like, okay, the IP SIM and IP AKA works great if you have a SIM, but what if you don't? What if you are not a cell phone that have an identity card in it? So how can we make different secure networks throughout be able to do the exact same thing we were doing with cell phones? So how do we authenticate these people over in our networks? Well, the Wireless Broadband Alliance has taken over the project, the open roaming one, and there are multiple identity providers. You can go and create an account with them, or your organization maybe already is a member and they just have this consortium where you join, and then they create an account for you and give you certificates. You can go in and download the certificates, and then whenever you go to an open roaming network, you just connect automatically. So now there is a consortium. Companies subscribe, they become members, and then they go through the guidelines that that open roaming has for them to be part of the consortium, and then it's just finding their names using dynamic DNS. And this is kind of like what it's going to look like. There's going to be a group of entities that are part of that consortium, and if you happen to have one of the accounts with them, then you're in. The certificates are going to have then information about the realms, the domain names, all the information they need to send you over to get validated and get on the network. And there are many members, and they're always, taking more people in, because they want this ecosystem where if you have one of those profiles, you go wherever, and then you connect automatically. You get on the train, connect automatically. Go to the airport, just connect automatically if you have Passpoint. But how does Passpoint work then? We keep talking about it. Seems like a marketing sales. You're like, you join the consortium. Like, okay, and how does this actually really work? So to configure your network as an access network provider, you will have to create an SSID. Whoa, that's so difficult. You create an SSID, and instead of putting a PSK or any of those authentication methods, you just choose .1x, and then you are going to enable Passpoint, and then you will enter the devices, in the device, the companies that you have agreements with. You add all of those operators, and some vendors will make it easier than others to add all of those to your organization. And then there are certain domain names and the roaming consortium identifiers that you have to add for the different entities out there, and specify what IP methods they're going to be utilizing. And then if you are using radios, then you're just going to need the radios credentials, because now you're going to have to worry about the IP address or the domain name for that radio server, specify the port that is going to be taking those, and then a shared secret. And then because now we're going to need authentication and authorization, so you have to enter all those credentials. Now, if you have RADSEC, you just have to enter a couple of domain names and whatever port you're going to be accessing the network in that one. Now, that seems like a lot of stuff to remember. Don't worry, we got you covered. We also created a checklist for you to know kind of like what items to look for and ask for when you are configuring your network. We will provide all of those checklists for you later. Then how does that then look in our network once we connect? Well, let's see if I can make this probably that good. Good enough for you guys in the back? All right. I like that. So there is a beacon frame. Notice that between the beacon and the authentication exchange and the association, that we all know how that works, there are a couple of action frames. Let me just move this to the right. So you're going to have an action frame going from the phone to the AP, and another one from the AP to the iPhone in this case. So let me zoom out of this guy again, and let's start looking at this in a different way. A beacon. So this beacon for open roaming is a betterized beacon. It's a smart beacon. It's a beacon with AI. Actually, no, it doesn't have AI. It's just a beacon with 3-4 new information elements, okay? That's what you have to look for. There's going to be an interworking, an advertisement protocol, roaming consortium, and then usually there's going to be a vendor specific for the Wi-Fi alliance. It's just a beacon. There's nothing about it, just a few more information elements. You're going to have the SSID, you're going to have that it has the AKM specified, and then the interworking element is going to have some items in there, like is this an internet enabled network, produces emergency services. There's going to be an ANQP, the Access Network Query Protocol, that is going to be specified in there, and then that's where the roaming consortium identifiers are going to be. View list for the Wireless Broadband Alliance or whatever vendor it is, that's where it's going to be. And that beacon is going to be announced every time. The Wi-Fi Alliance is going to have also that element in there. Now, let's talk about those two action frames. There's going to be an action frame, then generic advertising service, GAS, and it has information. The first one is asking for information. Basically, the client that is Hotspot 2.0 capable gets the beacon and says that, hey, this guy does interworking and it's offering Hotspot 2.0 services. So what this frame does automatically is that it's going to go to the AP and say, like, hey, you said you can do interworking and you can do Passpoint. What do you have? Then notice that it's asking, sending like, okay, send me a list. What's the list? And then the access point, the network advertising it, is going to have a response basically providing that list of things that it does. The rearms that it offers, the type of security they offer, and in regards to the 3GPP network, is going to provide the list, the detailed list of all of the vendors that it has agreements with to authenticate. And all of the domain names are going to be there. And then it comes the authentication. It's an open system authentication exchange, and then there is an association exchange, association request, association response. Now let's then look at the IP exchange that happens after the device is associated. It has an association identifier. There's going to be a request identity. This is from the AP to a client, basically saying, okay, identify yourself, please. Then this guy's going to respond like, okay, this is who I am. Notice that it provides the information about the mobile network operator and the 3GPP details. Then the access point is going to say like, okay, identify yourself then using the IP aka prime, which is the newer, better method. And then the phone, in this case, replies like, well, my desired method is IP aka, and it's like, okay, then using IP aka, provide your identity. The phone then provides its identity in the form of the encrypted IMSI. That's the International Mobile Subscriber Identifier. It's encrypted, and then there is a challenge that is going to go, and that is a set of keys that will be encrypted and exchanged back and forth. The client is going to provide, and it's just an IP exchange between the device and that mobile network provider. And then at the end, it gets an IP success, and it's in. That's it. Then it comes the four-way handshake, the PMKs have been generated, and now we're using that 1X, and we are authenticated against a different network. It's not that complicated once you have all of the pieces in place. That's what we've been talking about, and many people have mentioned open roaming and the consortium and Passpoint. That's what it's all about. Open roaming that's the map. It's online, and that's what they coverage they have right now. The idea is that whoever is a network operator, an access network provider, will have Passpoint set up, and anybody that has an open roaming profile, it will just connect. Now, think that you have a hotel and that all the Samsung TVs have already a profile in them. As soon as somebody plugs them in, they find a Passpoint enabled, open roaming enabled network, and they will automatically just connect to this network with without nobody typing any passwords or anything. So what tools are we going to use? Well, we use Wi-Fi Explorer to identify a lot of these items. Ceros has made changes, and now we can also do surveys and be able to identify what networks offer Passpoint and what are the ARCOs they are offering, so we can identify that on a survey as no different. You just do a survey, you're listening to these beacons, and then in the beacons, there is all of this information about the partnerships and the roaming consortium identifiers. So all of that information is there. And of course, we have another checklist for once the network is up and running, what to verify, what items to look for in a network so that it makes your job easier. And this, my friends, is how you create a network that provides access that is fast, free, frictionless, and now secure. And that way you will have the ability to have devices connected on your network, but they are authenticated against their home providers. And they can exchange encrypted data packets happily ever after. That's the end of my story. Thank you.